Trigonometric functions are fun. This is a human sine function. This is the y-axis, and this is the x-axis. This is the positive side of a sine function. This is the negative side of a sine function. We will be telling you in this video how to graph this function on paper.
This is a unit circle which has a radius of 1, and as we can see, I've already drawn a right triangle here, and I call this side is A, side A, and this side is side B. And the definition of sine x is this side over this side. As we already know, the radius is 1, so sine x equals side A over 1, which is A equals sine x. So I can express this side by sine x. Same way works as side B. So this side is cosine x.
Here I'm explaining why tangent x is equal to sine x over cosine x. As we know, in this triangle, the tangent is equal to the opposite over the adjacent. Here, the sine x is equal to the opposite, and the cosine x is equal to the adjacent. So we got tangent x is equal to sine x over cosine x.
This is how to make a sine graph. We use the unit circle and angle on the unit circle to make the sine graph. So if we start at 0 degrees or 0 radians, we can see that sine is at 0 as well. So we'll start at 0, 0. Then the next angle, you go pi over 6, which is equal to 30 degrees. We find pi over 6 here, and they're actually equal to 0.5. So we plug in our point at 0.5. Then also at pi over 2, we see that sine theta is equal to 1. Just like this, put a point at here. And we can continue all the way around the unit circle to create our 2 pi. We also can do this in a negative direction, as we can see that over here, this is actually pi over 6 is also equal to negative pi over 6. So negative pi over 6, we can go down to the negative 0.5 and plug in our point. And that negative pi over 2 is equal to 3 pi over 2. So we can go down to our negative 1 and plug in a point there. We continue through this to create the entire sine.
I already explained that how to graph the graph sine x function, and this is the graph of sine x. And cosecant x is defined as 1 over sine x. So we can use the graph of sine x to graph cosecant x. We can use the point like half pi, 3 over 2 pi, with sine of x equals to 1, and 1 over 1 is 1. So they get the same point there. And as sine x goes to 0 from the positive side, we can get a positive, very, very small number, like 1 over 0.0001, and we'll get positive infinity. So when sine x goes to 0 from positive side, that's this line, and this graph of cosecant x goes to positive infinity. And same way works for the negative parts, and when it approaches to 0 from the negative side, we can get 1 over a very negative small number, 1 over negative 0.0001, and we get negative infinity, and that's the fractions here. Sweet, as already mentioned that cosine is this side of this triangle. As we can see here, as the angles increase, this side is becoming shorter and shorter. So between angle 0 and 90 degrees, cosine, the graph of cosine is decreasing, and from 1 to 0, as we can see in the graph here, between 0 and 90 degrees, from 1 to 0. And this part it's becoming more and more longer, but it's in negative direction. So it's from 0 to -1, between 90 degrees to 180. And we can also see this in this function. And we know that secant x equals 1 over cosine x. So we can use this function to graph secant x. As you can see here, in this point, 1 over 1 equals 1. As the cosine function approaching to 0 from the positive side, it goes to positive infinity. So you can see when it approach to negative and positive 90 degrees, it goes to infinity. And when it approaches to 0 from negative direction, it goes to negative infinity. You can see that in this part. Sweet.
So we've got the graph for the sine x and the cosine x. Now what we need to do is just put sine x over cosine x to get the graph of tangent x. When the cosine x is equal to 0, like this part, this point, this point, this point, and this point, it's any number over 0 is equal to infinity. So we got asymptote here, 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 and here. And when the sine x is equal to 0, like here, here, and here, and also here, it's 0 over any number. It's constantly equal to 0. So you got those points. And when it's in a like from 0 to pi over 2, while sine x is increasing, the cosine x is decreasing. So the tangent x is getting larger and larger. So we have a upward trend. So it's like go like up, up, up. So that's how we get the tangent x. And also tangent x is defined as sine x over cosine x.
Now that you learned how to graph tangent x, we can figure out how to graph cotangent x by using the definition for cotangent. Cotangent x is equal to 1 over tangent x. So we can just pick a point for wherever tan x equals and just divide 1 by that number. Then we can just pick any number, so let's just pick where tangent x equals 0. Where tangent x equals 0, we can just do 1 over 0, so that would equal infinity for cotangent x. So there will be an asymptote. Those values are at 0, negative pi, negative 2 pi, pi, and 2 pi. Then we can also figure out where cotangent equals 0 by finding where 1 is equal, or 1 over infinity is. So we'll figure out where tan x equals infinity is at the asymptotes. So at pi over 2, cotangent equals 0. And also at 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Then we also know that as tangent x goes up, cotangent x must decrease, because the closer that tan x gets to 1, 1 over 1 equals 0. So it decreases there. But then when tangent x is negative, any positive number over negative number is going to equal a negative number. So cotangent x decreases as tan x increases. And so we can graph it here, and you can see that there's the downward trend throughout the graph. going from each asymptote to the next.
So here is how we reflect the graph on axis. For the reflection on the x-axis, we can just flip the graph on the x-axis like this. So we take the point on the original graph and put it on the other side of x-axis. So we got like, we do like over and over. So we got the reflected graph like this. So that's the reflection on the x-axis. And then if we do the reflection on y-axis, we can just like take this point and reflect on the y-axis, and we got like this and this, this. So it's basically the same thing for this particular graph, but it does not mean that all of the graph of trigonometry function are like this.
And I'm going to show how to do the shift of the graph of some function. The vertical shift depends on c in this formula. And if we set c equals to 1, and it's basically move the whole function upward one unit. And the way to help us draw this function is imagine we move the x-axis with by 1, and we can draw a line here, and imagine this is x-axis, and just draw the regular sine function here. So this is sine x plus 1, and the horizontal shift depends on d, and here we set d equals pi here. So it's by same thing, and just shift the origin function to the right side 1 unit, and by pi, yes. And another way to help it draw this function is imagine there is a y-axis here, and draw the origin x like this. Origin x, sine x function.
An application of a cosine function can be any rotating object. So in this instance, we have a ping pong ball. If we pick a point on the ping pong ball, we can show that over time, this point will rotate around as we roll it, like so. We can now graph the function, the cosine function, of the ball rolling, as we just pick a point, and we pick this point, which started at the top. And as this point rolls over, it rolls down to the bottom. And we said that the ball rolled over 4 times in pi seconds. So we have 4 periods here of the cosine function. So as this point rolled down to the bottom, you can see that it goes from 3 centimeters down to 0 as it touched the ground. Then that would be our point right there. Then it went back up again as it rolled up, and down again as it rolled down. So we can create the equation for this graph by finding the A value, the B value, and C value. There's no D value in this equation because the cosine function has no horizontal shift. So the amplitude is just the maximum and minimum point divided by 2. So we could take 3 plus 0 is just 3, and then divided by 2 is 1.5. So that's our A value there. Then we have 4 periods in pi seconds. So then that means that we would have 8 periods in 2 pi seconds. So that means that's our B value. Then our vertical shift is 1.5. As you can see here, our virtual x-axis would be right about there, which is directly in between 3 and 0, which is also 1.5. So our equation is y equals 1.5 cos bracket 8x plus 1.5.
Here is an application for the cosecant function. sound rise up from the